Hi everyone, today we're going to talk about how to graph quadratic functions. And to review, the graph of a linear function makes a straight line, and that's where the highest power of x equals 1. When written in the form of y equals mx plus b, you can figure out the slope or constant rate of change by figuring out the m value, and you can figure out the y-intercept or starting point by finding the b value. So now the graph of a quadratic function makes a parabola. And a quadratic function has the highest power of x being 2, where you have the squared. When it's written in the form of y equals ax squared plus bx plus c, we can use the quadratic formula, factoring, completing the square, whichever method to find the roots or the solutions. Parts of the quadratic formula can also help us find both the roots and the vertex value, and we'll talk about that later. A parabola does not have a constant rate of change because it's just constantly going faster or slower along that parabola. So let's talk about how parts of the quadratic formula can help us find both the roots and the vertex. As we know, the quadratic formula is x equals negative b plus or minus square root b squared minus 4ac all over 2a. By putting in the a, b, and c values, you can figure out the roots. And you all know now that to figure out the number of solutions, you can solve for the discriminant, whether it is positive, negative, whether it's a positive, negative, or zero value. It will tell you how many solutions there are. And then thirdly, the quadratic formula can help us figure out the vertex by using this part right here, the negative b over 2a part of the quadratic. So we're going to do some examples so that you can actually see that in action. So the first example from the book is example 12. Solve the equation x squared minus x minus 3 equals 0 graphically by drawing the graph of that function for the values of x that are greater than or equal to negative 3 and less than or equal to positive 3. So you know that before you could have figured out the x and y values, and you could have graphed those values using the x values that you put in to find the y values, right? To graph different points and connect them. However, now we know some wonderful shortcuts so that we don't have to do that. Let's start off by looking at our equation, x squared minus x minus 3 equals 0, and see if we can factor them into two binomials. Because I always want to try factoring first because it's going to just take less time. So I'm looking for two numbers that can add up to negative 1, but then multiply to get to negative 3. So I really am just looking at 1 and 3, and I can't get that sum or difference of 1 there. So factoring is out the door there. So now I'm left with either, completing the square, or I could use the quadratic formula. Okay, so I'm going to go with the quadratic formula. And actually, since it can't be factored, I already am thinking to myself that something's up with this solution, right? Like maybe it has decimals in it, maybe it doesn't have a real root answer. Something is up here, okay? So I'm just going to keep that in the back of my mind. All right, so my a value is 1, b is negative 1, and c is negative 3. X equals negative b, so that's a positive 1, plus or minus square root b squared, negative 1 times negative 1 will still be positive 1, b squared minus 4 times a times c, all over 2 times a, which is still 2. So I'm going to write that out. So 2 times a times c, all over 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 2 times a So then I get 1 plus or minus square root of 1 plus 12 over 2, which is 1 plus or minus the square root of 13 over 2. And there it is, right? We knew that something might have been up. Okay, so let's use our calculator to figure out what the square root of 13 is. That would be 3.6055. We'll keep it as that, 3.6055. So 3.6055. I don't want to write the entire thing down, but I also don't want to round at this point. I either have the answer of 1 plus 3.6055 divided by 2, or I have the answer 1 minus 3.6055 divided by 2. So I got two different answers here. All right, so I am going to use my calculator again, and I'm going to put in 4.6055, that's after I added, divided by 2. Take that and round to the nearest tenth. 2.3 then. 2.3. And then the other answer, if I can get my calculator out, the other answer will be 1 minus 3.6055 divided by 2, and that would be rounded to the nearest tenth, negative 1.3. Negative 1.3. So that means that my graph, since these are the answers for x, that means, and it was set equal to 0, that means that my graph is going to be touching the x-axis at these 2 points. Okay, so we got the y value of 0 from the 0 that it was set to. And then the x was the answer to our quadratic. So that's how we got these two values. We have our first root at 2.30 and the other at negative 1.30. Okay, 2.3 and negative 1.3. I'm just going to erase this real quick. So 2.3 and negative 1.3. All right, so it's going to, my quadratic parabola is going to be touching those 2 points. Now I need to figure out the vertex, because this could be either opening downwards, or it could be opening upwards. Most likely it's going to be opening upwards because I don't see a negative value here. Yeah, so if you remember, that a value had to be negative for it to be opening downwards. So I'm predicting a parabola that opens like this, upwards, and then like we said before, the first part of the quadratic formula, the negative b and the denominator over 2a will give us the vertex information. So if my b value is negative 1, my negative b value will be positive 1, and then 2 times a is just 2. So then the x is at 1/2, okay? Now, for a vertex, we need two coordinates, right? So I figured out that my vertex is at the x value of 1/2. I need to figure out the y value. To figure that out, all I need to do is just plug in my x value. So if the original equation was x squared minus x minus 3, and my x value is now 1/2, I'll put in 0.5. I'll plug that in, and then I'll figure out what the y value is. So 0.5 squared is 0.25. Actually, I don't need that parentheses anymore. 0.25 minus 0.5 minus 3. So now my final answer will be whatever that value or that answer is. So I have 0.25 minus 0.5 minus 3. So that means my y value is negative 3.25. Negative 3.25. Negative 3.25. Okay, so my vertex is at wherever 1/2 and negative 3.25 will meet up, which is right there. So then I can sketch my graph this way. And there we go. That's exactly where x is greater than or equal to negative 3 and x is less than or equal to 3. So it's going to look like that. Now I'm going to show you what it looks like in the book solution. Their graph is going to look a little different because their scale is different. Okay. Yep, there we go. That's their graph. So just like us, they had the roots at 2.3 and negative 1.3. Yep, right there. And then our vertex was at 1/2 and negative 3.25, which was right there. Okay, so we have two roots, which we found through the quadratic formula. And so we can say that this problem has two distinct real roots. Two distinct real roots. If we had checked the discriminant, we would have had a positive discriminant value. And we could have used that to predict as well. All right, let's take a look at example 13 from the book. Solve the equation x squared minus 2x plus 1 equals 0, and then you're going to draw the graph for it between these two values for x. Go ahead and pause the video and see if you can solve this one yourself. Okay, so if I were solving this problem, I would first want to see if I can factor it normally. So I'm looking for two numbers that multiply to 1, but can add up to negative 2. If you thought negative 1 and negative 1, you're correct, because this becomes x squared minus x plus 1, and these two get combined together to become negative 2x. So it's x minus 1 times x minus 1. Now remember, if that's set equal to 0, then we just set both of them, which are the same, equal to 0, and then you end up with x equals 1. Just one answer. So it's going to meet the x-axis at x equals 1 and y equals 0, because remember, we had set y equal to 0. So it has one root. Okay. We could use that same formula as we did before for the vertex, which was the negative b over 2a. So our b value is a negative 2, change that to a positive because we want the negative of that, over 2 times 1, which is still 2. So it's at 1, x equals 1. And remember, since the x value is equal to 1, we still need to figure out the y value. So y equals 1 squared minus 2 times 1 plus 1. So it equals 1 minus 2 plus 1. 1 minus 2 is negative 1. Negative 1 plus 1 is 0. So it ends up being 1 and 0. So that one is our vertex. So now we're in a jam because we need other information. We just have a point here now, right? All right. Because it turned out our root was the same as our vertex. All right, no problem. This is our x-intercept. That's where it touches the x-axis. We can figure out our y-intercept. X-intercept was at 1, 0. Y-intercept, wherever that will be the opposite. It's where the x is equal to 0 and the y is a non-zero number. And you're probably thinking to yourself, how do we do that? No problem. Okay, so if x has to equal to 0, then we'll just make x equal to 0 in the original equation. Our original equation, I'm going to copy back down here. And instead of x, I'm going to put in 0. 0 squared minus 2 times 0 plus 1 equals y. These cancel because they're zeros. So y equals 1. So our y-intercept is at 0, 1. Ooh, right there. Now it says that now I have 2 points. And so it could either go this way or, oops, put that point back. Or it could go this way, right? So which one is it? Well, let's look at our equation. I need to have a negative a value in order for it to flip and open downwards. I don't. So it needs to open upwards. Okay, so if I were to plot this now, it needs to open upwards. So it's going to look something like this. Yep. Let's take a look at the book and how they got their answer, or what they got for their answer. Yep, it looks like that. Theirs has a different scale, so it looks wider. Okay, but also it has a x-intercept at 1, 0, and then these are counting by 2s. So this is at 0, 1, because this is 1, 2, 3, 4, and 5. All right, so important to note that for this problem, we had a repeated root, right? We had x minus 1 times x minus 1. So it was repeated. So at the end, it actually ended up just being 1 root. And we usually call that an equal or repeated root. Okay. All right, let's do one more problem. Example 14 from your book. Solve the equation 2x squared minus 5x plus 7 equals 0 graphically. And then you're going to draw the graph for the values between x equals -1 and x equals 4. Go ahead and pause the video and try it on your own first. Okay, so let's see. Can we figure out some binomials that this will break up into? Let's see. I'm looking for something that will multiply to get to 14, but will add to get to the 5. So I don't really see anything. So since I don't see anything, then that probably means that something is going on. So I might have a decimal answer, or I might actually have no real roots, right? Because I couldn't figure out the factoring. So now I can either use, completing the square, or I can use quadratic formula. I'm going to personally go with quadratic because that's my preference. So here we go. X equals -b, so it's going to be +5, plus or minus square root b squared. -5 times -5 is 25, minus 4 times my a times my c, all over 2 times a, which is 2 times 2. So I get 5 plus or minus, this is 25 still, minus 8 times 7, 56, all over 4. So inside the radical, my discriminant value will be negative because 25 minus 56 will give me a negative number. I think that's -31, right? So since I can't find the square root of a negative number, I can't have a real number that will give me that answer, then this means automatically that there's no real roots. Okay? It doesn't mean you can't draw the quadratic graph. It just means that it doesn't touch this section here. It doesn't touch the x-axis. Okay? It's either going to be floating above it or it's going to be floating below it. Okay? So, but that discriminant will help us figure that out. And I know people who go right to the discriminant. They're like, I'm going to figure out the b squared minus 4ac immediately, because if it doesn't work out and I get a negative answer, I'm not even going to mess with the rest of the quadratic formula. Okay. All right. So what we could do is we could figure out the vertex, because that vertex could be floating above or below, right? It doesn't have to touch the line. So the vertex is negative b over 2a. That's the x value, at least. So this is positive 5 over 2 times 2, which is 4. Okay, so the x value is 1.25, or 1 and a fourth. We need to still figure out the y value. So 2 times 1.25 squared, right? Because I'm just going to put that 1.25 back up here for the x value, minus 5 times 1.25 plus 7. Okay, now I need my calculator. So I have 1.25 times 1.25 times 2. So that's 3.125, right? Yes, okay. And then minus 5 times 1.25, so minus 6.25 plus 7. Okay, and then I need to figure out what that entire thing is equal to. 3.1.25 minus 6.25 plus 7. 3.875. All right. 3.875 was our y value. So that's why our vertex is going to have these x and y values. Okay. So it's at 1.25 and 3.875. So the vertex is right here. Okay. So far, that's just a floating value. And then I do need to get some more information. So let's see. It's going to be opening upwards because this a value is positive. So at this point, I might need my table then. So let me put in the x equals 4 and x equals -1. Okay, because those are our boundaries. Okay, so once I figure out those values, then I'll just put in a little curve there, and then we're done. All right, so if x equals 4, let me just erase this so that I can see it. If x equals 4, then my y value would equal to whatever this answer is. So y equals 2 times 16, which is 32 minus 20 plus 7. 32 minus 20 is 12. 12 plus 7 is 19. Okay, so my first point will be at 419. Wow, that shoots way up there. And then for x equals -1, I can figure out that value by plugging in -1 for x. So I end up with 2 times 1, because this -1 squared is still 1. 2 times 1 is 2. This is plus 6 now. Oh, sorry, plus 5. Plus 5. Because -5 times -1 is +5, plus 7. Okay, so this is really 7 plus 7, which is 14. Wow, so this like shoots way up. So this is like all the way up there and all the way up there. Yeah. All right, it's a kind of like a skinnier graph then. And it had no real roots. Okay, for this one, it's the one from the book, it's gonna look different because their scale was bigger. Yeah, but as you can tell, it has the same vertex there and opening upwards. Those are the main points you should see here. And no real roots. Doesn't cut through the x-axis. Okay, so we went through a couple of strategies on how to figure out the roots, um, and how to just approach these problems. You should definitely try to factor first or use the discriminant, just to see what's going on. And then you can use the quadratic formula or the completing the squared, if that's what you prefer. And then for the vertex, you can either use the vertex formula that we talked about, or you can find the y-intercept by plugging in the x0. So lots of different things you can do. It really depends on the problem and what's going on. So, have fun with it. It's a huge problem solving scenario. And then, of course, as always, you can always just make an XY table, but that might take you forever to figure out the whole shape of it. Because you totally could just figure out all the values and then connect them together. But these are all little shortcuts for you. Okay? Let me know in class if you have any questions.